Hey everybody, welcome back. Um, Today we're going to be doing Remote Desk Part 1 again because I got a new computer. I went to the old computer, can't find the files anywhere. So we're going to do a Part 1, and this time I'm going to back it up to a cloud service. And when we're done with the entire application, I will post all the code available on GitHub along with the download link to the actual application. But for now, let's get started. So I just have an empty project here. C++20, by the way, as of this date, is now feature complete in Visual Studio. So I'm going to turn on C++20 because that will make everything a lot easier for us. I'm going to use the Windows subsystem, meaning that WinMain has to be the entry point. And I'm going to use, I don't know why it wasn't up there. C++ should be there somewhere. Maybe I need a file. Let's go ahead and create a main. And we're going to go ahead and create a class. This is just a shortcut for me for a header and a CPP file for our precompiled header. Now we're going to project properties. C++ is now there. Precompiled headers. I'm just going to double click to say we're using pch.h. Apply OK. Go to the precompiled header. And this will be used to create that header. So I'm just going to create a new filter real quick, call it PCH, and I'm going to move my precompiled headers in there. All right. So the first thing we're going to do, like we did in the last video, and I would also like to point out that I watched that video again, and there's like 5 bugs in the code. So for now, what I think I'm going to do is I'm only going to build the things that are necessary from the beginning for our app and make everything as safe as possible. So using RAII types, using the standard library as much as possible. Now we have standard ranges, which will help us a lot if we're using a lot of arrays or vectors. So we're going to be doing a lot of standard C++ along with this. But the first thing we need is we need windows.h, and then we're going to include Winsock 2. If I can spell. Okay, there we go. And I'm going to make a define here. That Windows 10 is just going to be required as a default for this. We're going to be using the DXGI output duplication, which is very low latency. It uses direct 3D, and this will allow us to send the data over the network from the client to the server side. And the server side is actually the admin controlling the help desk part of the application. So they'll be able to see the client screen. And from there, there will be inputs mapped to the window that will be sent over the network to the client's machine, and these inputs will be registered to the client's computer, probably via send input, because I think that's top level, and if there's a window that's currently there, that window gets direct access to the input chain. So I think we're going to do it that way. For now, though, we're only starting simple. So Windows and Winsock. Windows needs to be included before Winsock. Just a heads up with that, because if the orders are reversed, anytime you try to do a Windows specific function, it will claim that this item does not exist. So for some reason, Winsock 2 is self-containing unless you include Windows.h below it. I don't understand it. I really wish they would move that to modules, which is the next point of talk. We're going to be using C++ modules for most of this. Single code unit modules. Okay, so now we're going to include our precompiled header. We're going to create our entry point, matching the annotations just so we don't get any warnings. I don't know why I cannot spell it today. And we're going to unreference two parameters that will never be used in our application. So now we should only get two warnings that in command show and H instance are not being used, but that's not going to be true forever. Okay, so now that we have our entry point, what we need to do now is I'm going to do the same thing as before. So I'm going to add a module. And again, I'm going to use the same naming convention that I did last time with wrapping everything in the namespace remote desk. This way, everything kind of sticks together. I can use this code in the future and know it's referencing this project. So remote desk, Winsock, library.ixx. And for our precompiled header, we simply, I don't know why I keep doing stdafx, but so the precompiled header, this is the only weird thing I think that's with Visual Studio, but it's completely fine. Just type module before your actual export module definition, and in between these two, you can include your I forget what they call this. It's like the global segment of the module or something, but just know that's where your precompiled header goes, and then we only have, one header file, and that's the precompiled header. So we now have to rename this Winsock library. And I am also going to be throwing exceptions. I know it's like C++ and exceptions are forbidden, but on 64-bit, exceptions are not that bad, even if you throw them fairly regularly. The only issue is going to be in the real-time part of the application. Don't specifically go out of your way to throw exceptions. But even then, exceptions are fine. Because in a real-time environment, or let's say in a real-time loop, if an exception gets thrown, there's probably a major error anyway. If your code is written, like if you're loading files and an exception happens in real time, A, you're doing real time wrong, and B, your application should fail. So it should terminate. So just keep those things in mind. So we'll include std except. I'm also going to include system error, which is a operating system specific exception. This allows us to throw these, and it will actually give us information on what happened via the operating system. So Windows, in this case, has a set. They have a specific set of error codes, and Visual Studio's implementation of the C++ system error library is they actually will record the strings to you. So if an H result fails, you can actually get clear messaging on what happened. So I'm going to use system error for like H result stuff, and I think that's going to come in handy. All right, so now we just simply export our Winsock library. And it is, of course, a class. I'm also going to throw WSA data in here, just in case you want the data later. And this is where I messed up before. What I did is I had a bool in here, and basically the bool is set if it is initialized, and if it's not, then oh well, right? But if it is initialized, we can clean it up. If it's not, then we won't clean it up. But what I was doing is never setting that variable. If you pay attention to the first video, I'd never set the variable correctly. So this object never got cleaned up. Well, we don't actually need a bool, because if the library fails to initialize, this should be initialization time and not on a real-time thread or function call. Why not just throw an exception? And I think that will make things a lot easier for us to do. So constant startup result equals WSA startup Winsock version and MWSA data. So now we're going to come here. I already have it loaded up. we can look at the return value, and if successful, the function returns 0. Otherwise, it returns a error code. I don't I don't really care about the error code. I just care if the library successfully did it or not. So if startup result does not equal 0, we'll throw std. Now see, I may end up throwing just a simple runtime error, or I could do this. System error, startup result. System category. Like that. Okay, so now we have a system error. We give it the error, and then we give it a category. In this case, it's the system. Okay, and so that's it. Now we know that there was a system error thrown. All right, so what's next? We need a destructor. And with this, all we have to do is call WSA cleanup. And we can ignore the return value. Now, why is there no check if it is initialized? Because if an exception gets thrown in a constructor, this object is guaranteed not to be, I think it's guaranteed not to be constructed. Like there's no reason to do that. But just to be on the safe side, we'll do this, and then at the bottom is initialized is true. And then if m is initialized, then we'll clean up. So all we're doing here is basically setting it to true after it's initialized. If it is initialized, then we can call WSA cleanup. I may actually be wrong on the, like when you throw an exception here. I don't think I am. I don't think the destructor gets called if there's, yeah, I think that puts the object in an invalid state. Anyway, just to be on the safe side, it's a single byte. It's nothing. So I just put that is initialized there. And so now we have a library. Now, do we care about copies? This is another important thing. What's being copied? The data and is initialized. However, what will happen is the copies can corrupt each other because you do have this WSA cleanup call. So I think what I'm going to do is not allow copies. And this one should be operator equal. So copies are disabled. But what about moves? Do we only want one of these objects to be created? Do you want them to be able to be, let's say, moved to another thread? I think yes. Like, so I'm gonna allow moving. And all we're gonna do here, right, is we simply just need to set lib dot is initialized to m is initialized. Oh, I'm sorry, the other way around. M is initialized to lib dot m is initialized. I've been writing in other languages, so I'm kind of rusty, but and then lib dot m is initialized equals false, and that right there will get rid of anything that could happen. But there's a one-line way to do this, and that's with std exchange. So I could do std exchange lib.m is initialized, and I can set that to false. And so what this does is it sets its value to false, and whatever's in this value gets exchanged. These two get swapped. This original value gets stored in mine. Okay, and that's all that's required there. And then we want a copy. What is this? A move copy operator or something? And I actually do have a habit of calling this right-hand side because it's on the right-hand side of the operation. And all we have to do here is the same thing. Oh, I did the wrong thing. and then just simply return pointer this. Okay, we don't need any other functionality because we don't have to actually check if it is initialized because otherwise it will throw an exception. And then all I have to do is const WSA data, get WSA data, all right, and this is my Winsock library. So now, in order to check this, we need to actually go through in WinMain. Let's go ahead and import our Winsock library. And we're getting errors for some reason. Did I set it to C++ 20? I hope I did. I did. Yeah, I don't know what's going on, but anyway, it should have compiled. Wait, is it doing that weird thing again? Is it Winsock before Windows? I just remember it was one of them, and it was really weird. It's Winsock before Windows. Like this is what I'm talking about. This is why I don't really like header units. Now we're getting a link error. So now I can go back into the project properties, go to the linker, and I can add additional dependencies. ws2 underscore 32.lib, and yes, underscore 32 is even used for 64-bit applications. Don't worry about that. And now when I start, it returns 0. So now we'll go into the module. We'll check startup. I don't understand what's going on here. Okay, it's calling that. It's calling that. And we're all good because the destructor got called. Perfect. Okay, so now we know that it is being initialized. For some reason, though, again, modules are still experimental in Visual Studio, but it's not even going into this. Maybe if I step into it. Okay. There we go. Startup result is 0. So we don't throw an exception. And is initialized is false now, and then it will be true. It calls the destructor like it's supposed to. And of course, we don't have to actually test anything else because, well, we should test to see. Yeah, let's go ahead and test to make sure this works, although I know it will. Winsock 2. Oh, I know why I renamed it, but that doesn't matter because I'm testing it anyway. All right, so we know that it's initializing. So when we do this move, okay, the right constructor is being called. Is initialized is being set. Lib is turned to false. Ours is turned to true. So we'll continue. So window 2 moved right now is in true, and Winsock 2 should be in false. It is. Okay, and now in Winsock 2 should now be in a valid state. It's true, and window 2 should be false. Perfect. So we know that of course, there's no copy. We deleted those. And you can move these, and the constructor, destructor, everything's being called correctly. Okay. So we're done with the Winsock library. Just like that, it is being initialized. Okay, and we're just calling Winsock library like that. Boom, it's initialized. Winsock is now initialized. It's the first thing going on in the application. And just to make sure everything returns 0, we'll check out our errors and warnings. No errors, no warnings. Everything's perfect. So this, I'm going to create a new filter called Winsock library. And I'm going to move my module in there. Actually, I think I'm going to rename this and just call this networking. These are going to be networking related modules. I think it's going to be easier to search for it that way. All right, so now the next thing I'm going to need is, like the last video, we're going to stick to IPv4 and TCP because it's going to be plenty good enough for what we are trying to achieve. And I only am going to create 2 classes, I think. I think I'm going to create a TCP server and a TCP client because I think that makes sense. We don't need all the functionality of sockets, so I don't want to create an entire socket library. I just want to create what I need. So I think I'll start with the TCP server. Okay. But now we do have a small problem because a socket is created, but it also needs to be destroyed. So this is the perfect example of, where we need an RAII type. On construction, you set the object, and on destruction, it gets cleaned up for us automatically. And standard unique pointer can actually do this, except there's a problem with sockets. First off, they're not pointers; they're basically ints, and the invalid value for it is not null pointer; it's invalid socket value, I think, or invalid socket. So we need to create a class that's going to come in handy because we're also going to create a handle to a window where we want the same kind of delete functionality. So I think what I'm going to do is I'm going to create a utility filter, and I'm going to add a new module. And I'm just going to call this a Win32 resource. Or should I call it unique resource? Something generic so you can use this in other projects if you want to. I think I'll call it unique resource. So same thing as like unique pointer. It can only be moved, it can't be copied. So we're going to have a template, type name, resource type. I know some people don't like extensive names in their templates, but I do. Type name deleter, and then we need a resource type, invalid resource value, which we're going to default to null pointer, but this way we can change it later. And we're simply going to requires std is pointer v resource type. Oh, nope, we can't do that actually because a socket is not a resource. Okay, well, this is fine right here. We'll just call this unique resource. I hate when it does that. Get back over there. Let's see. We need a resource type. mResource is, and we'll default it to invalid resource value. So with a unique resource, we'll have a default constructor. We'll have an explicit constructor where we can pass in a resource type. And we'll just set our resource. I need to get used to doing this because this is valid too. All right, now I need to disable move. I'm sorry, disable copy. I don't know why it's trying to save. Okay, and I need to provide a move constructor. And a move assignment operator. Okay, and so now all we have to do here is take our resource and we set that to std exchange with resource.m resource invalid resource value, like that. So the move constructor is done, but now we have to do this basic same thing here, except I'm going to set that equal instead of constructing it, and simply return pointer to this. Now there's nothing special here other than this resource type, so this is a perfectly valid solution. Now we need a reset function, trying to keep things close to how the standard implements, plus com pointers, which we'll go over later, use this exact functionality. So we have this reset, and I think we'll take in a resource type and just default it out. And I think I actually need a couple functions. So bool is valid. We'll also make this whole thing no except. Is valid basically is the resource not equal to the invalid resource value. And here, if this is valid, we need to create a deleter. I'm just going to call it deleter, and I'm going to pass in my resource. Okay, so we'll delete it if it's valid. Otherwise, we will do our resource. And just to make things, just in case it doesn't get inlined, it probably will, but just in case, we'll move that there. And last thing I want is I want a function to release ownership. And I'm being very specific here. And I'm also going to mark node discard. So you can't ignore the return value. This is, again, C++. I think C++ 20 is no discard. But if not, it's maybe 17. So we can just return std exchange m resource of an invalid resource value. So now again, keeping all this code really small and short means that it takes nothing to test it. So now we have this release ownership. The only other thing we need is we need a resource type. We'll call this function get return m resource. And I'm just going to have a explicit operator bool And again, just in case it doesn't get inline, I'm gonna write a little extra code, but it's a single value. Just double checking all these. All right, everything's good. So now that we have removed constructors, we can now and we'll call this reset. And since it's defaulted to the invalid value, this will clean up the resource. I don't even have to test the destructor. I just have to. I know this will work too. I'll call the deleter, and I know this works. So I'm doing visual code review right now just to make sure everything is exactly as it should be. The only ones that concern me, M resource, I'm exchanging. Look, caught the bug. Caught a bug. RHS.mResource. And I'm exchanging that resource with this value. I'm getting that resource's value. And this one, we're doing the same thing. Okay, everything looks good. It looks like now we can. Yeah, see, now I know some people, they'll use no discard on like things like a return value that shouldn't be ignored. But maybe there's a reason for it. But in this case, release ownership, it can cause damage, right? If you can actually cause a leak if me as this API designer, you come along, use this, and it's not marked no discard, it's actually the designer's fault that your code messed up. In this case, if you call release ownership, I'm telling you, you can't ignore what's being returned. So if something goes wrong due to this, like a leak, it's your fault. So this takes the responsibility off of me if, later on, this class has no responsibility to what happens after release ownership is called, and you cannot make that more clear by simply saying, I'm giving you the resource and invalidating the one I have. You cannot discard this return value. So, yep, that looks like that's it. Everything else is good. Copy is deleted. Okay. I am going to go out on a whim here and just say that it's good, but just to be on the safe side, I'm going to do a unique resource, and I think what I'm going to do is just for now, I'm going to create a deleter that doesn't do anything, just so we can test this. And I'm just going to make it with socket. I'm going to create a struct up here. Mark that no accept. And what I'm going to do here is I'm simply just going to do socket equals. I'm going to create a function. I'm afraid that the compiler shouldn't optimize this away, right? If I do a simple return, I will know that it's reached that. It shouldn't optimize that away. And here I'll just do a using unique socket. Will default construct one. We'll set this a value. And then what we'll do is we'll simply do socket 2 equals and now socket 2 should be valid. So this right here we're going to check all our states here. Again, this is not like writing proper unit tests. I don't care about that right now. As we get into more model code, I will do that, but this is perfectly valid. There's like 3 or 4 functions. If full is valid equals socket 2 dot is valid. bool is not valid. Socket 2 dot is valid. Bool op bool equals, or let's say op is valid. Socket 2, and then we'll auto socket equals socket 2 dot release ownership. Unique socket will pass in the socket. And so these should also be all of these values here. And then I'm going to call reset on socket 2. Okay. So there should be one call. All right, so the first socket's being created. Socket, obviously, that's the invalid value, so that looks good. Socket 2 is being initialized at 55, resource is 55. Socket 3 should be what socket 2 is. Socket 2 is now invalid, socket 3 is 55. Now socket 2, I'm going to move that from, because that's testing the operator equal. So socket 2 is 55 and socket 3 is invalid. And so now we'll check all our valid states. Is valid is true, it should be. Is not valid is false, because it shouldn't be. And then op is valid, and that's true. So these are good. Socket, and then I'm releasing the ownership. So now socket should be 55, socket 2 should be invalid, it is. All right, socket 2, I'm recreating that with this socket, so that gives me that resource. I don't know why I did that, retest it anyway. And then socket 2, M resource should be 55, and then when I call reset, it should call this operator. It does. And then socket 2 should be invalid. Boom. Just like that. We're good to go. And now we just got to test that the destructor works. And so the way I'm going to do this is I'm simply going to come here, socket 5, something simple, and then we'll simply make sure that the destructor is calling this, and it is. Boom. All right, everything looks good. So now, I'm cleaning up main again. So now that we have our networking, we're going to create a new module. So we can call it unique socket. I'm going to call it safe socket or auto close socket, something like that. I think I'm just going to call safe socket. What the hell that was? So basically the same thing that we did last time. We'll create a socket deleter. And we'll simply call close socket. So now we have to import unique resource. And this is now our safe socket. And all we have to do now is, I'm thinking we can export this entire namespace and then wrapping this in an anonymous namespace, and that way this does not get exported. Because again, there's something really weird that happens. I'm also going to mark this as final, just in case it does get exported. I don't want people inheriting from this. That's kind of dangerous. This is a deleter. But anyway, so I'm just exporting the entire namespace. So now we should have a safe socket. We'll come back to WinMain, import safe socket. Remote desk has no member safe socket. What is going on? Well, I guess it's not that bad if they can see this, right? Something about using has been acting kind of funny. Does that compile? It compiles and runs, but for some reason, this safe socket thing here, yeah, this is an IntelliSense bug, obviously, but it's fine. We'll get this working. They'll get this working eventually, and this code will be good. So I do know now that safe socket works. I just wish they would fix some of this. It's a lot better than it was even a few months ago, so I'm kind of impressed. But so I'm thinking what I'll do. Can you just export the safe socket and not that? Socket deleter is there, but not safe socket. Yeah, it compiled, so that export did work. I don't know why you can access socket deleter. Anyway, it's not that important right now. That's the way it is supposed to be written. That's the way I'm going to write it. It'll probably take a couple months to get this application done anyway. Probably like 50 videos. All right, so now that we have a socket deleter, it's now time that we create a basic TCP socket and server. So this TCP server, we're going to export class TCP server, which basically is a listener, or it should have a listener, and then it should have clients that connect. Ooh, yeah, so I do need actually a TCP socket. And I know some people are going to say you should use Boost, you should use another library that's already written, but that's not the point to this. The whole point to this is to, for those following along, that this is all possible writing native code, which you'll see me do. And you don't need third-party libraries, but you will see how valuable those third-party libraries actually are. Because half of this code that I've already written has already been done. But if the user, if you're following along, I recommend writing the code along with me, because you're learning valuable things. Like, for instance, the safe socket, you're learning about modules. You're learning about RAII types, which now we've created two of them. We have this unique resource, but then we also have the Winsock library, which is an RAII type wrapping a library. So anyway, we're going to import safe socket, export class TCP socket. So again, IPv4, so we don't need anything. This right here will create a socket. So let's go ahead and implement the constructor. AF INET IPv4 sock stream and IP proto TCP. So it's an IPv4 TCP socket. So we could throw a runtime error, or again, we could throw a system error. And again, this is part of the system. Get the system category. All right, so now we have a socket that we can just use, and if for any reason it fails to create it, it'll throw a system error, and that'll give us more detailed information, like for instance, the error code, a message regarding what happened. Again, ignore this. I know this says that this is unidentified, but or undefined. It is defined. This is IntelliSense freaking out. So just don't worry about that. I'm hoping that as the videos progress, you can actually see the module system and IntelliSense kind of work together to make the code more fluent. So now that we have a TCP socket, the cool thing about SafeSocket, you can't incorrectly use this. I don't have to write a destructor, even external libraries. Because I'm using SafeSocket, it's move only. You get a implicit move constructor and an implicit destructor that automatically calls this. You don't have to write any of that. So there's so many benefits to using RAI types like this, because it just saved me, like, I don't know, 2 minutes of writing code. Like I can just, oh look, I now have a UDP socket. Save socket, M socket. There it is. You're good to go. Okay, so now we need to provide some functions. Bool. We're going to have a connect. Now, TCP socket, we kind of want sock address underscore in address, and we'll just make that a const reference. So we're going to connect to that address. That's what this connect does. We're going to have an int send. Okay, so now I'm thinking we go ahead and we add some other system containers like string, because I want to work directly with strings, because it's basically a vector that you can resize and everything's in bytes. So I don't know why I keep flipping back and forth. I'm trying to find it. There it is. So const std string send data. And then receive data. So I'm thinking I still return like the default int. Ooh, how do I... I'm thinking I'll actually do a bool, whether or not the data sent successfully and whether or not we received. Yeah, I think I want to send and receive like this. And here, number of bytes. And here, I'll return the number of bytes that were received. And this way, the API looks very similar. You give me a string, and you get a string when you receive. Okay, so that's looking good. So the connect I just called that get on the socket. This is the only weird stuff. Okay. So that's connect. That should connect. And yeah, so that should connect. If it doesn't, it should return false. Otherwise, it returns true. Send. And last but not least, I'm just going to do flag 0. I don't know why I set that there. And here we'll simply just return send. Let's see what send returns. Send function. Where's the return value? What's about, yeah. If no error occurs, number of bytes sent, which can be less than the number requested to be sent in the link parameter. Otherwise, a value of socket error is returned, and a specific error code can be retrieved. Okay. So, first off, if data empty, I'm going to return 0, because that is basically an error. We sent 0 bytes. And then constant send result. If send result equals socket error, return 0, otherwise return 1, or return send result. So what we're basically saying here is if the data is empty, return 0. Basically, you gave me an invalid input. I could throw an exception, which actually I may end up just doing that. Getting rid of this entire thing. Data is empty. Yeah. And then simply throw it. And we have the send result here, which, yeah, basically if it's an error, we just return 0. Otherwise, we return how many bytes were sent successfully. And then it's up to the user to, consider that. Now, this is the only problem here. If data.length is greater than numeric limits int max. Oh, we can do a define here to get rid of something. I don't want min max. Okay, so all we're doing here is we're getting the size for this and the max. This should be, yep, so that's the max for an int value. If the length is greater than that, we're going to throw std, what is that, out overflow error. Data length is too large. Okay, perfect. So now we have a way to filter out the data's length, and we're getting that, and if the data is empty, we'll throw an invalid argument. Okay, so now when we receive, this is going to be hard. First, if number of bytes is less than or equal to 0, throw std invalid argument. Number of bytes to receive must be greater than 0. Okay, otherwise, constant receive result equals receive. Now our buffer. This is where stuff gets fun. So we're going to resize our bytes. Oh, and then we need a constant flags 0. I'll make that const too, why not? That way they know I'm not changing it. So now we need to look up our receive function. Right there. If the connection has been gracefully closed, the return value is 0. Otherwise, a value of socket error is returned. Okay. If receive result equals socket error, we'll return an empty buffer. But see, that doesn't directly communicate what happened. Maybe there's a real error. I should throw a system error. So WSA get last error in system category. And we're basically just going to copy this if it is a if received result is 0, this is a special. Here I'm going to do the buffer clear, return the buffer. And then otherwise, we're just going to simply return the buffer here. But I think that I want to have a bool m is connected. And then here we'll just simply return the buffer. All right, and here what we'll do is m is connected equals true. And we can actually get rid of this, but it may be an invalid address. So I'm thinking I'm still going to stick to this, the way of doing this, instead of throwing an exception, specifically because it may not be an exception if you connect. If you are receiving data and there's an error, like for instance, like the client disconnected on their end, then yeah, that would be an error. So maybe I'm just going to throw a system error. It does not matter. Okay. And then last but not least, bool is connected. Okay, so we can receive bytes, we can send bytes, we can connect. Now, what about binding? Maybe yeah, and that gets rid of this. That also gets rid of this. And actually, that gets rid of connected too, because if you call connect and it successfully connects, and yeah, then an exception will be thrown. So that is completely useless now. You'll know you're connected if you're transmitting. Yeah, that's good. And we'll return an empty buffer if there's a graceful disconnect. So that's how you can check it. Just check that the buffer's empty. Um, all right, so now we'll have a bind function. That's saved. That's what I'm talking about. So then we can bind, we can connect, and then we also need to be able to accept. And I think what we're going to do is we're going to accept a second. So I think I'm going to have a private constructor. And the way this one's going to work, first off, let's mark it explicit. Give me 1 second. Now that we have our socket, we can also no accept this. All we have to do now is simply pass this to our socket. So we have a private constructor here that will help us with our accept function. So now we can take in a TCP socket. We can accept a new TCP socket. Let's look up accept and see what the return value is. If an error occurs, accept returns a value of the socket that is descriptive for new socket, return for the handle, otherwise a value of invalid socket is returned. Okay. So what we can literally do is we can call accept we don't need those addresses. So if that socket is not valid, we can throw system error. Oh, hold on. Watch this. Boom. Otherwise, we can return the socket. Okay. All right, so now there's only one real way to test this code, and that is to basically open up a client and a server. And I'm going to have to remember exactly how to do that on my end, but I think we can try it now. And after this is going to be the end of this video. And then we will come back and we'll do part 2 next week. And I will continue this. I'm going to back this up on a cloud server this time. And I'll release one video every Saturday. To TCP. Yeah, let's just start with a TCP socket. So that right there should create our TCP socket. Sock address underscore n, sock ADDR. I'm just going to do like a C style thing. Family AFINet. The port H. I'm going to do like 2302. That's a port of a game that I like, that I'm always having to connect the servers on that port. So assign address. And you have to go into the union, get the address hton l. And here we're going to call in address any, since we're binding. Then listener dot bind. And then listener dot accept will return a client. And then on the client, we can receive and send. Cool. Now this should just lock up the program because I'm trying to accept a connection, but there's no real timeout. Oh, I forgot to do something. You know what I forgot to do? We need a listen function. I'm just going to default that to 1. And then if listen result equals socket error. Okay, otherwise it's listening. Now we can come back out here. Once we bind, we need to bind to an address on our system. Then we need to listen. And now we have a client accept. Oh, look at that. Boom. Now I'm really thinking I may be able to just spawn another thread and connect locally. Yeah, this is some of the hardest code to test. But I have a listener up, and as you can see, the program's just stalled because I'm trying to wait. I'm waiting for a connection. So I'm wondering if I go back here and I include thread, and this will be the last thing before the video ends. All right, so std thread. Yeah, before I do that, let's create a thread. Call it client thread. And all we have to do here is now we can do our client stuff. Here we'll accept, and then I want to do auto message equals client dot receive, and I'm going to pass in the number of bytes that I want to receive, and I'm just going to do 10 as my max for now. And then I'm going to message box A, my message C string. And so this is how I'm going to test this. So now that I have a client, I'm going to create a TCP, remote desk TCP socket, and then socket.connect, but we need a sock address. We have a family of AFINet, H tons. We'll do 2302. And address dot ton L host to network long, and we will do our in ADDR loopback. I think is that's the local host. So we're gonna try to connect to that, and then if we connect, and then we're going to do socket.send. We'll send the message. And then at the end of this, oh, there's one more thing that we need to do. Graceful disconnect. So we can set it up in such a way. So we have our socket. We are going to create a personal destructor. And all we need to do here is we need to call shutdown. We're going to ignore the return value because we don't really care. If it's not connected, it doesn't matter. So we're going to shut down our send in. They should receive that. Actually, I'm just going to shut down both. Okay, and then everything else should be fine. I am just for sake here, I'm going to delete my copy and default my moves. And this can also be marked no accept because that's what it is. And I don't plan on opening this up to virtual, but yeah, for now this is fine. Everything looks like it's going to work just fine. The only thing left, I think, is we may need a way to physically shut down. So maybe once you disconnect, so shutting down the socket just shuts down both. So this shut down, and then the destructor for the safe socket gets called. Okay. That looks like it's perfectly fine, and then the other person, so you can gracefully disconnect early. All right, so now that we have this, socket.receive, I want to receive 10 back. Okay, and so here we're going to get the message. We'll do a message box. After that message box, this thread should quit. And actually, yeah, I'm going to call so client.shutdown. And that should oh duh. So I'm getting hello, disconnected. Boom, everything exited. So I'm getting the message that's being sent. So I'm gonna say hi there, just so you know I'm not like being weird. So the client thread's sending hi there. This the main threads or the client thread's now saying disconnected because we shut down. We gracefully shut down. Now without that, what you will see is there you should see hi there. Oh, and then disconnected instantly because again, when the client gets destroyed, it's shutting down. So that way, graceful disconnect is not an option entirely, unless the corresponding API does not support it. So anyway, um, this was this was fun. In the next video, we will create a listener, an actual client, and then we'll implement our TCP server and our TCP client. So the client is going to be something that the listener pushes out, or I'll call it a server client. A server client is something that a listener pushes out, and it's basically it's just a TCP socket, and a let's see, yeah. So the TCP client will be for the client's side of the software. TCP server will be for the admin's part of the software. There's a listener and then a server client. Those are used both on the server's interface. Okay, and then after that is done, we will be completely done with our networking code, everything that we need anyway, because we won't need anything specific. I may add something to get IP addresses if that comes up later on, but that's a simple, a few lines of code. So for now, I'm going to delete these tests now that we've tested them. I'm going to straighten up my library. And so the only thing that's the next thing again is we're going to implement a TCP listener. So that'll be the next thing. I'll go ahead and delete TCP server. So we'll implement a TCP listener. And I think what we'll do is we'll go ahead after we get the networking stuff done. We'll go ahead and start some Win32 stuff. This way we can get a basic window up and we can go over some of the messaging and loop operations that need to take place so we can successfully run the window correctly. And then I think after we get some basic Win32 down, we'll go over Direct3D initialization, creating textures. We'll import a library called DirectX Toolkit and DirectX Texture because that's a million lines of code. I'm not about to implement that. I'm sorry. But yeah, everything else is perfectly in order. So that's all that's needed left is the Direct3D stuff, Win32 stuff after the networking. And then we'll have the core model. We also need an input library. Something when the admin has quote unquote control of the client's computer, if there's input in the window, that input needs to be translated, normalized to the client's system. So like for instance, if your window is bigger than the entire monitor on the client, you need some way to be able to know, okay, I'm this far in the texture on the mouse. I need to normalize this so that way I can denormalize it to the client's perspective. I can send correct inputs. So, there's going to be a lot of math involved later on, but for now, everything's pretty simple. You should be able to follow along. And this Winsock library, we're going to do another one of these to initialize COM because we're also going to enable Direct 2D and Direct Write because we're implementing the UI ourselves, which is going to be fun. That's going to be probably the most fun. So anyway, y'all have a good day. Look forward to my videos every Saturday now that I'm a little more dedicated and I have a new PC. Look forward to getting new videos every week. It's going to be only this, and maybe I'll post some C++ exercises, something that can get your guys' brains moving. Anyway, have a good one. We'll see y'all next time.